today's lesson, we are going to be learning about the quadratic formula. Before we get into that, though, we want to do a little bit of a warm-up and look at how many roots do each of the following parabolas have. Now again, just a reminder that another word for roots is x-intercepts. So how many x-intercepts does each parabola have? Well, we take a look at the first one, A. We can see that it crosses the x-intercept here and here. So in this case, it crosses twice, so there are two roots. For B, the second one, we can see that our vertex is right on the x-axis, meaning that it does touch the x-intercept or the x-axis once at the vertex and then moves up from there. So in this case, there is one root. And then finally, for C, we can see that its vertex is above the x-axis. It's not crossing the x-axis in any way that we can see, and based on the arrows, it's not going to at any point. So in this case, we could say there are 0 roots. So what the quadratic formula does is that it helps us find the specific roots. Right? We looked at how to find roots previously. Right? In factored form, we are able to find them easily. We're able to convert standard form to factored form by factoring. We could do the same thing with the vertex form as well if we really wanted to. But what if we can't factor it? If we can't factor it and get it into factored form, then we're kind of out of luck. And that's where the quadratic formula comes into play. So the quadratic formula can determine the roots or the x-intercepts of a quadratic equation in the form ax squared plus bx plus c, which is our standard form. And ideally, this formula is useful when the quadratic equation cannot be factored easily. So if we cannot factor it using the product and sum or the tricky trinomials or any of the other methods, we can use the quadratic formula. However, even if we can factor it, the quadratic formula will work for any quadratic in standard form. As long as we have that a, b, and c value, we can use the quadratic formula, which we can see here is x equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. So in this case, right, we can go through and basically we're just plugging in values and then solving. So how many possible solutions can this give us? Well, we know in the end, right, the different scenarios that we could come across based on the warm-up that we just did. But how many solutions could we get from our quadratic formula? Well, in this case, we should be at least looking for at least 2 solutions. Right? We should be looking for at least 2 solutions, and the reason is because of this plus minus in our formula. Because it's a plus minus, that means we have 2 parts or 2 scenarios that we have to do. Negative b plus the square root of b squared minus 4ac, and negative b minus the square root of b squared minus 4ac. So when we go through and we solve the quadratic formula, you'll see that we're going to branch off our formula or our solving into the 2 different scenarios, one where we add and one where we subtract. Because that's what that plus minus is telling us. It's telling us to do both. Now, what that results in the end could vary, but the idea is that we do need to go through and do both. So let's use the quadratic equation to solve each of the following for its x-intercepts. Right? This does look like a simple trinomial. Right? We have our a, our b, and our c value. B we can clearly see is 7, c we can clearly see is 5. What's our a value? If we don't see a number in front, when we're multiplying, we can assume it's 1. This is our simple trinomial. So we could go through and try to factor this, right? But you're not going to find factors that multiply to 5 and add to 7, right? So again, you could do the partial factoring to find the vertex, but we want to find the x-intercepts. So in this case, we are going to have to use our quadratic formula. So negative b plus or minus the square root of b squared minus 4ac all divided by 2a. So from our formula, we're just going to go through and plug in our values into the specific spots. So negative b, the negative is part of the equation, so you always start with a negative. If it's a negative negative, or our b value is negative, then we can cancel it out, return it to a positive. But we want to start with that negative there. So negative b, so in this case negative 7, plus or minus, let me just move this down a tad, negative 7 plus or minus the square root of 7 squared minus 4 times 1 times 5, all divided by 2 times 1. Go through and solve, or continue to calculate. So negative 7 plus or minus, we can solve this square root. So we solve this square root because we can do 7 squared is 49, minus 4 times 1 is 4, times 5 is 20, all divided by 2. So this becomes negative 7 plus or minus the square root of 29 divided by 2. And now here is where I would split it off into two parts. So we can do negative 7 plus the square root of 29 divided by 2, and negative 7 minus the square root of 29 divided by 2. They're both just calculations. Right? Depending on what calculator you're using, you may have to take it or solve it in a few more steps. But if you have a fairly competent scientific calculator, you probably do it in at least one step. So the first one we get is negative 0.807 for one x-intercept, and our second one, negative 7 minus the square root of 29 divided by 2 equals negative 6.19. Let me just double check that first one. Make sure I didn't make any calculation errors. We're good. So these are our two x-intercepts. So we have an x-intercept at negative 0.807 and one at negative 6.19. So these are our roots or our x-intercepts. Same thing. So again, we can see how we wouldn't be able to find those two values by factoring because they're not nice values. So that's where the quadratic formula or equation comes into play. Go through another example. Same idea. Now we have a different value for a. Right? We have an actual value that we see. So this would be a tricky trinomial. Again, we could try to solve it, but again, it might be easier just to use the quadratic formula. That way we don't have to worry about, am I using the right factoring method? I can just plug my three values into the formula and calculate. Right? Again, the quadratic formula or equation works regardless of if you can factor it or not. Some people may find factoring easier, so they may choose to do that. But you can always use the quadratic equation. So negative b, or in this case negative 8, plus or minus the square root of 8 squared minus 4 times 3 times 3, all divided by 2 times 3. So negative 8 plus or minus the square root of 64 minus 36 is 12 times 3 divided by 6. So negative 8 plus or minus the square root of 28 divided by 6. And at this point, this is where I would split it off. Now again, you could find out what the square root of 29 is and then solve or replace that with that value, because then it's just negative 8 plus or minus a singular value divided by 6. It's up to you, but this is generally where I would start to split it off. Negative 8 plus the square root of 28 divided by 6, and negative 8 minus the square root of 28 divided by 6. So again, just two calculations, very similar, just one is adding and one is subtracting. We end up with negative 0.45 as one answer, and then negative 8 minus the square root of 28 divided by 6, negative 2.22 as our second answer, which again, these are both x-intercepts. So again, you could see we would never be very difficult to find those values by factoring it in the previous methods that we learned. Finally, we have a word problem. So this is where the quadratic equation becomes more useful in terms of finding the x-intercepts, because not all scenarios or models are going to be using nice values. Right? So we may not be able to factor all the equations or models that we get. So a model rocket is launched upwards at a velocity of 16 meters per second from an initial height of 1.25 meters. The equation that models the height of the rocket is h of t is equal to negative 4.9 t squared plus 16t plus 1.25, where t is the time in seconds and ht is the height in meters. After how many seconds does the rocket hit the ground? So when it hits the ground, right, if we think of how this parabola would work or this quadratic would look, rocket would go up in the air and then come down. So presumably, it's going to have two x-intercepts. One, we're assuming, should probably be close to 0, and the other one is going to be where it hit the ground. So we can figure out what is that time. So we have our formula. We have an a value of negative 4.9, a b value of 16, and a c value of 1.25. This is enough to use our quadratic formula. So x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. We have negative 16 plus or minus the square root of 16 squared minus 4 times negative 4.9 times 1.25 divided by 2 times negative 4.9. Negative 16 plus or minus the square root. I'm just going to solve the inside. So 16 squared minus 4 times negative 4.9 times 1.25. You get 280.5 divided by 2 times negative 4.9, negative 9.8. So again, this is the point where I would split this off into two parts. Negative 16 plus the square root of 280.5 divided by negative 9.8, and negative 16 minus the square root of 280.5 divided by negative 9.8. So when we go through and solve, right now these are just two calculations. The first one we get negative 0.08, so essentially almost 0, which we kind of predicted at the beginning anyways, and negative 16 minus the square root of 280.5 divided by negative 9.8. So we get 3.34 as our second x-intercept. So in this case, this is basically saying that our rocket is going to take off at negative 0.08, essentially 0, and land at 3.34. So after how many seconds does the rocket hit the ground? Therefore, it hits after 3.34 seconds. So again, just using our understanding of what the quadratic would look like and what the x-intercepts represent. In this case, this x-intercept represents how long it's going to stay in the air or how long until it hits the ground. The final one, how high is the rocket after 4 seconds? Well, this is very similar to what we did all the way back at the beginning of the course. But 4 seconds, this is basically saying that t is equal to 4. So we could replace all the t values with 4, or you might say h at 4 is equal to 4.9. It should be negative 4.9. Negative in there, negative 4.9 t, or not t, because it's now 4. 4 squared plus 16 times 4 plus 1.25. And now we're just going through and solving. So negative 4.9 times 4 squared plus 16 times 4 plus 1.25. We do get a negative value. Again, this would not make sense, but we'll go through and solve for it anyways. Negative 4.9 times 4 squared plus 16 times 4 plus 1.25 gives us a height of negative 13.15. Now, graphically with our model, this would make sense. However, logistically, how can we have a height of negative 13.15, which is true, but we can see from the previous question that the rocket will have already hit the ground. So unless it can drill into the Earth, this rocket is probably going to be at 0. But based on the model says that it's going to be at negative 13.15. So if it had the ability to continue following the path, this is where it would end up being. But the main idea is just if we're trying to find the height after a specific time, we just plug that value into the equation for t and then solve. And again, don't forget we have a minus there, or it's minus 4.9. So the main thing from this lesson is just understanding how we can use the quadratic formula to find the different roots or x-intercepts, understanding that we are going to have two solutions, or at least two solutions for our quadratic equation because we have to split it off for the plus and the minus when we're solving. So again, just making sure that we can find the values from the standard form, plug it into the equation, go through and do the calculations, and then come up with our two answers for our x-intercept.